Our solar system occupies a space so vast it is difficult to visualize. Past the outer planets lies the heliosphere, a boundary where the sun's magnetic influence finally begins to fade into the trillion-kilometer reaches of interstellar space. Reaching that frontier is an immense challenge. In the entire history of spaceflight, only 2 human-made spacecraft, Voyager 1 and Voyager 2, have ever successfully crossed into the void between stars. Every night, telescopes capture thousands of images, tracking faint points of light that move against the fixed positions of distant stars. This process led to the discovery of Comet MAPS. As scientists calculated its motion, they noticed a significant anomaly. The object was traveling at an extreme velocity relative to the Sun. Gravity dictates a strict speed limit for our solar system. For an object to have formed here, it must move slowly enough for the Sun's gravitational pull to keep it trapped in a stable, bound orbit. The kinetic energy of Comet MAPS is simply too high for that to be possible. Its speed indicates that it is an intruder, moving with enough force to escape the Sun's gravity entirely. Most local comets originate in the Oort Cloud. This is a massive shell of icy bodies surrounding the solar system that occasionally sends a frozen object falling inward toward the Sun. This 3D map shows the standard orbital pattern of an Oort Cloud object. Because it is anchored by the Sun's gravity, the comet must follow a closed, elliptical loop that eventually brings it back to where it started. The path of Comet MAPS is different. Early calculations suggest it is traveling along a hyperbolic trajectory, an open arc that does not form a loop. A hyperbolic path means the object is not gravitationally bound to our star. It is using our solar system only for a gravitational slingshot, with a projected path that will lead it permanently back into deep space. This open geometry rules out the Oort cloud as an origin. It confirms that the comet is merely passing through our system once before returning to the wider galaxy. To find where this object came from, we have to look back into the dark regions of interstellar space. Objects drifting between stars can wander the galaxy for billions of years. The distance between star systems is so vast that encountering a new sun is a rare event that only happens after immense spans of time. There is a high probability that Comet MAPS began its journey long before the Earth had even finished forming. During this transit, the absolute zero temperatures of deep space keep the comet completely frozen. Without heat or light, the chemical composition of the ice remains perfectly preserved. This deep freeze is what makes the object scientifically valuable. It is an untouched chemical record of the environment from an ancient star system. As Comet MAPS enters the inner solar system, its billions of years of stasis end. The warmth of our sun is beginning to heat its frozen surface for the first time. This heat triggers sublimation. The ancient ices on the surface rapidly vaporize, releasing jets of gas and dust trapped inside for eons. This material forms a coma, a glowing cloud surrounding the nucleus, which solar radiation then pushes outward to create a long, luminous tail. This thermal activity is the only reason we can study the object. It transforms what was once an invisible dark rock into a bright beacon that can be seen by our telescopes. This chart shows how astronomers analyze light from the coma. Breaking it into individual wavelengths reveals its specific chemical composition. If this barcode mismatches local comets, it provides a direct record of the environment where Comet MAPS formed. NASA and the European Space Agency are currently focusing their most powerful observatories on the comet, gathering as much data as possible before it moves back into the outer solar system. Usually, we must spend decades building spacecraft to sample other worlds. Here, the universe has delivered a sample directly to us. Comet MAPS is a rare, fading data package. It carries the chemical signatures of an alien star system, information we must record before the object disappears.